Hello and welcome back to Caffeinate Math. This is hypothesis testing part 2. If you haven't seen part 1, go watch that first. Today I'm going to walk you through an example so you can see how the steps of hypothesis testing work. Okay, here's the problem, and it's taken from this book, Basic Statistics for Business and Economics, the 8th edition. According to the Census Bureau, 3.13 people reside in the typical American household. A sample of 25 households in an Arizona retirement community showed the mean number of residents per household was 2.86 residents. The standard deviation of the sample was 1.2 residents. At the 0.05 significance level, is it reasonable to conclude that the mean number of residents in the retirement community is less than 3.13 persons? Okay. Let's go back and we're going to read it a second time, highlighting important information as we go. Here we go. According to the Census Bureau, 3.13 people reside in the typical American household. A sample of 25 households in Arizona retirement communities showed that the mean number of residents per household was 2.86 residents. The standard deviation of the sample was 1.2 residents. At the 0.05 significance level, is it reasonable to conclude that the mean number of residents in the retirement community is less than 3.13 persons? And now we'll just make a quick list of what we found. So the population mean is 3.13. We have a sample size of 25, sample mean of 2.86, sample standard deviation of 1.2, and a significance level of 0.05. We'll need that mean and less than a bit later in the problem. So just hold on to those for now. Okay, the first step of hypothesis testing is to state the null and alternate hypotheses. So we'll need an H sub 0 and an H sub 1. I like to start with the H sub 1 because it's often stated in the question. In this case, the question is asking if the mean number of residents is less than 3.13 persons. So there's our alternate hypothesis. Mu is less than 3.13. In contrast, the null hypothesis is the assumption that mu is greater than or equal to 3.13. Remember, the null covers all the ground that the alternate hypothesis doesn't cover, and vice versa. And remember, again, equal is always in the null. So that's it for step 1. Step 2 is to determine the significance level. Easy step because, hey, it's given in the problem. So we'll just write that down. You can say alpha equals 0.05. Now for the hardest part. Determining the test distribution. I'm going to pull up a decision tree that I've used before so you can see how I do this. Now you can make your own decision tree based on what tests that you need to be considering. I know I'm dealing with one sample, just the Arizona retirement community. So let's zoom in on that section. I know from the problem that we're working with the mean, so we go to this side. And finally, the problem told me the sample standard deviation, which means that the population standard deviation, sigma, is unknown. And here we have our formula from the t-distribution. So we can now add that to our working problem here and move on to the next step, which is the decision rule. Here, we need to define the rejection area. We need to draw a line in the sand between what we'll accept and not accept. So let me show you how this works. We're dealing with a t-distribution, so I'll bring up a t-chart or t-table. Since our hypothesis is only mu is less than, we're looking at a one-tailed distribution. And of course, we know that the significance level is 0.05. Therefore, our critical t value will be somewhere in this column. Now on to the degrees of freedom. For a one-sample test, the degrees of freedom is found by n-1. So if our sample size is 25, our degrees of freedom is 25 minus 1, which is 24. And here we have our critical t-value of 1.711. Okay, back to our problem. We write reject h sub 0 if t is less than negative 1.711. Notice these two signs match, but why is it negative 1.711? Good question. Let me draw you a picture. Because we are interested in whether mu is less than 3.13, then we're dealing with the left side of the curve. The t-table shows us the absolute values, but our critical value will be below 0, and therefore negative. Our rejection area is anything below negative 1.711. And finally, we get to do the math. This is the fun part because we finally get to an answer. So we just plug what we know into the equation. 2.86 minus 3.13 divided by 1.2 divided by the square root of 25. Plug that into a calculator and we get negative 1.13, which falls about here on our graph. So, okay, what does that mean? Well, let's go back to the decision rule. We reject the null if t is less than negative 1.711. Since negative 1.13 is not less than negative 1.711, then we do not reject the null. Or you can say we failed to reject the null. And now the last step is to, well, we got to translate that back into English. So in this case, if we fail to reject h sub 0, that means that the mean number of residents in the retirement community is not less than the typical American household. Voila! A successful trip through hypothesis testing. Each step serves a very important purpose, so don't skip any of the steps. Good luck with your testing, and I hope you discover something really interesting in your analysis. I'll see you next time.